All right, so in this lesson, we're going to go over upper and lower boundaries. So go ahead and write that in your spiral. This is one of what I think the weirdest lessons because it's one of those things that seems super obvious and easy and then also complicated at the same time. So just bear with it and then, of course, ask me any questions if you have them. So to find the upper and lower boundaries of a class, we're calculating the mean, and that's your average, of the upper value class from one class and then the lower value from the following class, okay? So you should be thinking, okay, what's a class? First of all, that is your group, so this is going to be another vocabulary word. You obviously need to know your upper and lower boundaries. And then to find those, you need to know that you're using the mean, the average. Okay. So looking at example 5, we're trying to find the upper boundary of the first class. So go ahead and read this whole thing. Okay, so this is talking about flowers in a garden. So my first class is this 0 to 10 group, second class 10 to 20, third, fourth, and fifth. So class is just a fancy way of saying what group are you in. So for the lower class boundary, I'm just looking at this data. 0 is the lowest class boundary for that first group. Because I'm talking about flowers in a garden, the heights of flowers in the garden. So they're either there or they're not. I can't have any negative amounts. So it makes sense that 0 is my lowest. Okay, and they took measurements of this, and I don't have any reason to suspect that I have flowers that are beyond 50 centimeters. So my upper class boundary here would be 50 for that last group. From here, we go and figure out all the middle ranges, and that's where that average comes into play. So it says that you take the average from the upper value of one class and the lower value class of the other. So we're going to start with the upper bound of this class because I already have the lower bound, which means I have to take the average from that next step up. So I'm doing 10 plus 10. And we divide that by 2, and I obviously get 10. Okay, the upper class boundary is the same as the lower class boundary of the next class, so I know that this one is 10. Because that would be the same as me taking, oh, this is my lower class, I got to compare it to the one before. Then I do upper class for that group, so we've got 20 and then 20, so if I were to do 20 plus 20, I get 40. Divide that by 2, and that's obviously 20. So if you want to take a moment, go ahead and pause this video and fill in the rest of your table. Okay, so that's what all of this looks like. So if I'm looking specifically at the upper boundary of my first class, this is my first class, and that would be 10. So for A, my answer is 10. For B, the lower boundary of the third class, I say, okay, first, second, third class, I care about the lower bound, so that is 20. So, looking at this all together, notice that when they gave us the group, we went everything up to 10 and then starting at 10. So there wasn't any gap between these groups. So when I'm finding the boundary, I'm looking for the minimum and the maximum of what would belong to that class. This one is a super easy and obvious example because we start and stop in very clear places. But sometimes there are gaps along the way, like they may go from 0 to 4, then 7 to 10, something like that, and that's when this average will kind of tell you a little bit more. So, looking at a different example, we have example 6. Okay, so read this one to yourself. Okay, so instead of talking about flowers, we're now talking about shoe size. So this, to me, is where everything starts messing with your brain. So up here, we said the lower class was 0 because that's where it starts. And the upper class boundary of my last group is 50 because that's where my data stops. Over here, if you're looking at this, we're talking about shoe sizes. So this is a sample of all of the shoe sizes that exist, because there are definitely feet that are smaller than a size 15, and then there are more that are larger than a size 44. So this is sample data from a larger population that we definitely know about. So because of that, my lower class boundary is not 15. I'm actually going to need to say, all right, if there was a class before, we know based on this pattern, 20 to 24, 25 to 29, that my last group probably stopped at 14 and began at 10. My bad. So pause, see if you can figure out how I got this, and then tell me what the class would be after. Okay, so you should have found that that next group was 45 to 59. Okay, so again, we're doing this because we know shoe sizes exist without or outside of this range. So to find the lower class boundary of my first class, I have to compare it with the upper class boundary of the previous one. So I'm now finding the average between 15 and 14. So 15 plus 14, you divide that by 2, you're going to get 14.5. I know that looks like a 9, but it's not. So 14.5. Okay, and then my process is always to go to the upper bounds of the last one, which means we need to compare it to the lower bound of that group that we know exists. So we're finding the average between 44 and 45. Okay, so that should be your setup, and you would get 44.5. So that is where the upper class boundary of the last one will be. Okay, so again, this is where it's weird. You have to think about, do I know if anything exists previously or after the data that we have in the given table? So go ahead and fill out your values for the rest of the table here. So this should be what your lower class and upper class boundaries look like. Yellow is 39.5. 39.5, this is 29.5 if my handwriting is difficult for you to read. So upper boundary of the first class is 19.5. Upper boundary of the last class is 44.5. So you have two answers for part A. For part B, the lower boundary of your first class is 14.5. And the lower boundary of the fourth class, 1, 2, 3, 4, is 29.5. So again, you have two answers for part B. Okay, so good luck. I know it's weird, but think about, does anything exist beyond the data given? And that'll help you with the lower and upper bounds of the whole table. And then just take your averages.